Okay, thank you very much, Professor Preeti Tiwari, Professor Rajlakshmi Chauhan, for this kind invite, and really happy to be here. Excited to see this kind of a workshop that has been organized on this occasion. So let me just share my slides, and then I can get started. I hope it's visible at this point.
Yes,
Yeah,
it's visible.
So before actually going to the core research part of the talk, I thought I'll spend a few minutes talking about our department, what our students are trained in, what we've been doing, how we came about, and so on, because it's a relatively new area, especially as an academic discipline. This is rather new, especially in India, and even worldwide, it's interdisciplinary and it's more recent. So our department, it's called the Interdisciplinary Program in Education Technology. And in IIT Bombay, an interdisciplinary program is essentially a small department. It's just a different name. We have a PhD and a master's program. The PhD program, we began in 2010, just over a decade ago. Right now, we have 5 core faculty who have training in the learning sciences, discipline-based education research. For example, so my background is in physics education research. One of my colleagues is in CS Ed research. Other faculty who've been trained in HCI, human-computer interaction, and so on. We also have about 15 to 20 associate faculty from other departments in IIT Bombay. Engineering departments, science departments, the humanities and social sciences, design school. In fact, quite a few collaborations with the design school and so on. We have postdocs and research staff. Currently, I think we have 32 PhD research scholars who are enrolled and 17 alumni over the past decade. And we just about started an MTech program. So our first cohort graduated this year. So I just wanted to give you a sense of, who we are, where we started, and etc. What do we do? So it's like any regular department in any IIT. So the primary mandates are research and teaching. In terms of the research projects, we have both student-facing projects such as the technology-enhanced learning of disciplinary practices. This is what I'll spend most of the time today discussing. And there is also another teacher-facing project called Teacher Use of EdTech. So I'll talk about that a little bit in the intro itself. We have 2 more recent thrust areas, data analytics, educational data analytics, which 2 of my colleagues are working a lot in it. And the 4th one you see here, emerging technologies. This is more like an area which we use as a playground. So there's a lot of hype, right, around AR, VR, more wearables. And one of the goals as serious academics and as researchers, we thought that, okay, let's actually explore these, find out what they're really good for, where's the hype, where's the reality, design some curricula, some small activities around it, do some small studies. So we use emerging technologies a lot in our course projects at this point. In terms of development, so this is both technology development, technologies to support teaching processes, such as there's a tool called ISAT for teachers to do some analytics, then also technologies to support students. And we've done a lot of MOOCs development, both on SWAYAM and IIT Bombay's platform over the past decade. Lots of outreach. The last year, of course, due to the pandemic and lockdown, everybody had to move online. So one of the major outreach projects we undertook was to create a self-paced, web-based course called OTeach, or online teaching. And this initially we started this for our own colleagues, and then it kind of got very popular. It has some 25,000 hits by now. Please feel free to go and use it. It's all in Creative Commons. The idea is it starts with principles, the main principles of online teaching, talks about some pedagogical methods, some tools, some comparisons, and so on. And then there were some workshops based on it. We've been doing a lot of faculty professional development programs, and last year we also did a virtual hackathon. So this is just to give you an idea. And of course, like any other department, we do teaching, consultancy and sponsored projects with industry, NGO, governments, sponsored research labs. So we have one research lab that's endowed by an industry. And by the way, at any point, if you have any questions, do put it in chat. I have the chat open, and I'll also take certain pauses at some points. So, quick overview of research. I won't talk much about the first one right now, the tech-enhanced learning of disciplinary practices, because that's sort of the bulk of the talk. But very, very briefly, this is going beyond concepts, rooted in concepts, but going beyond concepts and studying practices such as engineering design, such as data interpretation, problem solving, troubleshooting, where students and learners, they have to synthesize concepts from sometimes multiple domains or even within a domain from multiple topics and actually do what scientists and engineers do on a day-to-day basis. So for this, we've built what we call as technology enhanced learning environments. I'll show you a lot of examples about that shortly. In the teacher use of education technology products, we build models and frameworks. So the main one, like Professor Preeti mentioned, is called the LCM or learner-centric model. And then that's this thing. It's like an instructional design model for the instructors to enhance engagement and cognitive engagement and and promote learner diversity in very large scale MOOC settings. Emerge projects, like I told about, these are just two examples. So this one here is actually interesting. This is my student Ashutosh. He's wearing a bracelet. This is a wearable, it's called myoband, and it senses muscular twitches. So he just did this as a course project to develop or to help students figure out whether their badminton shots, how close is it to experts. So in terms of its power, the rotational frequency, many other parameters he measured. So what you see on the graphs in the back, the blue graph here is actually experts and the red one was students. So this was just a toy project to begin with, but it was to show that you can push these technologies to do some interesting things. This is a standard AR application of a 3D stereochemistry molecule. The lady who's holding it, this was actually in school teacher workshop in the local Kendriya Vidyalaya. And the one on the right is data analytics. Okay, coming to teaching. Okay, so the list you see here is actually our coursework. And this is, I mean, the title says what our students are trained in, because this is part of, I mean, this is their integral coursework. There are 2 or 3 courses on learning theories, 2 on research methodologies, where one broad one, and then they specialize either quantitative or qualitative, sometimes mixed methods. We use a technique called design-based research quite regularly. Again, these methodologies are borrowed from social sciences. So the field is very interdisciplinary in that sense. Learning analytics is a new course we started. A few courses on instructional design and on integrating technologies for and marrying them with the effective pedagogies. Those are the central group. And then few other specialized courses on evaluation, analysis, and so on. Okay, the last overview point I wanted to make is we also engage with stakeholders. So this is sort of a very new project that we have begun in our department. My colleague Chandan and I are the PIs, and we are engaging with an NGO and also talk a lot with state governments in coming up with standards for good edtech. So the different stakeholders here are product companies, state governments who have to do procurement decisions, and also, of course, schools and teachers and parents. So the idea is the project has sort of 3 parts. We are first coming up with quality standards for personalized and adaptive learning systems, for audiovisual material. Then we evaluate actual commercial products. And then we use these, the image on the right is how we were trying to get one of the state governments to use it. So we are trying to, this website is up, it's right now a static website, but in a couple of months, we are planning a major launch. Okay, so later, if you have any questions about any of these facets, please do let me know. Before actually diving into the research, I did want to make one point that EdTech actually, I mean, when we hear of educational technology, we very quickly think of the tools, AI-based assessment, virtual reality, something 4.0, because that is attractive and that's current. It's also there in the markets. It's people are talking about it. They do have potential, but the philosophy we use in our department is that it comprises both technology for learning, which we call as, which are the tools, as well as the technology of learning. So again, if we go back to the dictionary and look at the word technology, it has two parts. One is the tools and devices and machines and so on. And the second is the science underlying all of these. So the underlying scientific processes, methods, concepts. Indian Institute of Technology, the word technology, I think there also really means both of it. So when we talk of educational technology, this duality we do keep in mind very strongly. And I would say often we do lean towards the technology of learning. We do use tools. It's not like we don't use tools at all, but we keep bringing ourselves and our students and all back to the learning processes, the pedagogical strategies, the mechanisms of how learning happens. In our department, we are focusing mostly on individual and small group learners. Of course, there's a lot of edtech overall in the world that's also looking at systems and all. So I won't touch upon that much today. Okay. Any small clarification questions or anything now? This is a good pause point.
Yeah, so actually I would like to know that because how you started, what are the, if you can just share your
Sure,
story
I'll go
of
back.
the starting, because we are also going through the same phase,
Okay,
which is there.
thanks for asking that. Okay, I was a little hesitant initially to talk about it. So I'll just tell you how the genesis. Okay, so over the past, I think more than 20 years, several faculty members in the discipline departments have been working with technologies in education at IIT Bombay and in many other institutes. In late, so around 2008, 2009, 2010 and all, the government also had a big initiative called the National Mission in Education through ICT. So it was a 6,000 crore project, so 1 billion USD project, mainly to partly for network in intra-college network, inter-college and all, and a large amount for content creation using ICT. So IIT Bombay, or NPTEL, for example, is the flagship project there. So the government was putting in a lot in this. Publishing houses started moving from traditional book publishing towards more ICT materials. So this is sort of the context, at least in the country. And in our institute, we had several projects. At that point, so due to various other factors. So I was in the US. I was looking to move back. So IIT Bombay is my alma mater, and I was thinking of moving back to Mumbai or somewhere. And there was a big discussion in the institute that look, we need people who are trained, who have academic expertise in these areas. So it kind of it was a good match in that sense. So when I joined in 2009, actually we didn't have a department at that point, but we were a group of people trying to get things going. And then the Senate of the Institute decided in 2010, early 2010, that look, the best way to do this is to start a formal program, an academic unit. And in IIT Bombay, IDPs are sort of, they can be born very easily. So climate change is a new one, any new interdisciplinary area, it's easy to get them going. And at that point, there were like two of us faculty and again 15 odd people. We started a PhD program because we said we're doing research. It's always easier to start there than BTech is very, very hard. And I don't even know if we are planning to do that. So we started with 4 courses and we had a lot of, we had our students take courses from the design school, from the social science department, some from the School of Management. So it was sort of a little bit of jugaad, I would say, of the program itself. But in about 2, 3 years, 4 years, we stabilized. And in the about 5 years ago, we recruited more faculty. So now we're a stable department, and we grew from 6 PhD students in 2010 to the numbers you see now. So, I mean, Preeti, this is sort of a very informal, casual discussion. I mean, narrative. So, if there's anything else to ask.
Yes, yes, absolutely. Because how the starting of the story, because right now we are also, we don't know, we just on the basis of the like-minded people, come together and started this, and especially in the COVID time where the things is very challenging.
Right.
Student can just switch off your camera and we don't know how to engage
Yeah,
them, discuss.
definitely. So there's a lot of recommendations about that. The only minor caution I have, not really minor, one caution is that, online learning, or especially in emergency times like COVID, online learning and teaching during emergency times is not the same as systematic research in a discipline, even though it borrows from it. So that is some, the difference between, there is an article that came out last year called The Difference Between Emergency Remote Teaching and Systematic Online Learning. So these kind of differences, I think it's worth keeping in mind. The last slide I had, I'll show it to you at the end, is, if you want to start, I think any organization that would like to start should start thinking more in terms of a research program, recruit faculty, and start an academic program. Then all the other parts, they will, it's not like they'll magically fall in place, but because IITs need to do all of this in addition to this, all of these will start growing. May not be linear, may not be smooth, but they will. This is the part where, this part and the teaching part is where we need a lot of some people who are trained in these fields, any of these fields actually.
So actually one question, because I see you also teach this design thinking. And here also I am also teaching this design thinking specifically for the entrepreneurs. And I am facing particularly the problem of engaging the student, because design thinking is some course where they have to do, we can't give all the gyan and they have to listen and all those things. Is there anything, the courses where a lot of activities is required? How can we, how can we make or maybe the technological intervention can solve this problem, which
maybe we'll take this at the end, this one. So
sure.
We don't teach a course in design thinking ourselves, but the IDC School of Design does some of it. And I know that IIT Madras actually had a course for all its BTechs, all its first year, second year BTechs, 1,000 odd students on design thinking. It was, so if you want to see, a live example for the BTechs, I think it ran for more than 10 years, maybe close to 20 years. I'm not sure if it's running right now. But IITM did have this course. Of course, it's problem based. And students would be given a problem, small tutorials, they would design something and so on. We have the luxury of, having numbers like this, like tiny numbers. So what we do is we sort of do a lot of, all our courses are hands-on. Everything here, all of these are hands-on. Most of them are discussion-based courses, with some are on the field and so on. Okay. So let me just carry on, just keeping an eye on time. I'll try to do this part in about 15-20 minutes and then, go back to other open questions. So why disciplinary practices, and, it's a mouthful, and why is it important? So let's just spend some time on that. So this is a question. If I ask all of you, what is it that we want our students to learn and to do? Just quickly put in chat anything that comes to your mind. Just remember, I have said to learn and to do. Okay, just put some stuff. It will give you a sense of what. Or you can unmute and speak also. If there are students in the audience, I'm not sure. You can just translate this question to what is it that you would like to do during your graduation. Okay, understand. Good. That's where we start. Anybody else? Let's try to unpack this word understand a little bit, okay? As in, what can we think of getting a bit more specific? What does understand really mean? And that's why the whole lot of problems come, because this word understand is so huge and it means so many different things.
So, this thing is, something, most of the time we try to superficial the course, but, the basic, which is there, okay, this thing I know, this thing is very common, this is very generic. So sometimes what happens is we just, I think we superficially try to understand, but not the, what you can say, the core of what is the soul of that particular course, which is there.
Okay, so the core conceptual understanding, that's one way we think about it. Problem solving skills. Thank you, Professor Gaurav. Learn the basics and be able to build on it. Learn basics and application. Absolutely. So when we really start thinking about this, we start coming up with these sort of specific things we want our students to learn and be able to do. So if we look at literature, okay, both literature as well as policy. So this list on the left, we see, of course, we want them to understand content. So you see, I've put the word understand as the first word and in quotes. Concepts, the hierarchy of concepts. If you ask a physicist how many core principles are there, they might sometimes even say something like 3 or 1, 5. They won't say 58. And so there is a hierarchy and connectedness of all concepts. Of course, we want them to do that, but we want them to solve problems. We want them to model phenomena, design systems, analyze, troubleshoot. We want them to critique, do argumentation. And we want them to be able to work in teams, communicate. So there's a whole list. And this list comes from, it comes definitely from research articles, but it also comes, so the US has something called ABET, which are the standards for engineering. Comes from there. NGSS is the science standards for school level. NMEICT is our own national mission. There was a project 10 years ago, which was anchored in IIT Kharagpur and had about, I think, close to 30 or 40 institutions in the country, where we were trying to look at engineering curricula and break it down into these kind of outcomes. Okay, so this is what we want our students to do. One caveat, sort of something that I need to scope my talk. This is largely science and engineering focused. That's my background. I know nothing about humanities, and so that will be my lens. Okay. Okay. Now, if we ask a slightly different question, okay, it's actually a different question. What do scientists and engineers actually do in their day-to-day professional practice? We see a list of things, and if we put them next to each other, it's not surprising that there's a link between them. I mean, there's a mapping. The reason we want our students to do all this is because this is what they will be doing in their professional practice. Again, this list is both from research as well as policies and professional organizations. So all this is great, but if you want a formal definition before the but, let's just take the first one. These are practices or behaviors that scientists engage in as they investigate and build models and theories about the natural world, and those that engineers use as they design and build models and systems. Okay, so this is sort of a two-part. The first part is slightly more towards the basic sciences and the second part towards the applied. And then there are some other definitions. Examples are engineering design, hypothesis generation and testing, data representation, data interpretation, computational thinking. I haven't put problem solving specifically here because it's a bit broad. What type of problem solving, right? So design is also a problem, estimation is a problem, troubleshooting is a type of problem, analysis is a type of problem. So these are what we mean by disciplinary practices. Why disciplinary? Because let's take hypothesis generation and testing. There's something which is pan-domain, pan-disciplinary in it, but the way it manifests, the way it operationalizes, one has to start with the domain-based concept. So one has to really be rooted in the domain and then use these practices. Let's skip that. If you have any other practices, just put it in chat or speak up. There is a point by Professor Chibber. What about ethics? No, absolutely right. Ethics is super important. I agree. Now, in the literature, till recently, ethics, social justice, and all were sort of sitting outside of disciplinary practices. Nobody argues that they're not needed. They are needed, but they were not within this the scope. What is happening in the learning sciences very lately is inclusivity, social justice, ethics. These are also kind of coming closer. My work so far has not touched those primarily. That's why I don't want to. I mean, I don't know in more detail about it. But you're right; these are important, and of course, we have to make sure our students get it. So, one more point about practices. Sometimes you hear alternate terms like thinking skills. Some people call them. These are all related ideas, not identical, but they're related. Scientific habits of mind. I've heard that. Transdisciplinary habits, 21st century skills. So there's all these terms. They're all roughly similar to each other. Okay, what is the problem we are facing? So let's look at it. So if you have heard any of this, just in your mind, you can raise your hand or you can put it up. Students saying that, oh, I learned or studied or know the concept really well, it's just that I can't solve the problem. Now, as a teacher, how many times have you heard this? Or as a teacher, you may have said, I showed students 7 examples of how to apply it, but only a few could solve the problem on the test. Now we are faced with this issue also. And in a slightly more systematic way, there is a very well-known, I don't want to say famous, but just well-known, infamous, if you may, reports like the McKinsey report, which says, I have not put the year, but they've come up with it many times, that only 25% of our engineers are employable because they don't have necessary skills. We have to retrain most entry level. So the fact that practices are not automatically developed, this is the key point. Just because we teach the domain and we may teach it really well, unless we explicitly focus on these practices, on the learning of these practices, students don't automatically develop them. They're challenging. So knowing the domain concept is not the same as applying practice, even though one is required for the other. The main thing is that students need to apply these practices reflectively and critically. And we as instructors and as curriculum designers need to address this very, very explicitly. We need to design activities. We need to give them feedback on the learning of these practices. So that's sort of the need that sets the motivation for the research that we've been doing in this disciplinary practices. So how do we do it, right? We've set up a very tall requirement. What next and how do we do it? So what I'd like to do is just go through a few projects in this thrust area. So it's not a single thing. That's why we call it a thrust area. The way we've approached it is when our PhD students join, most of them have, they all have a master's, but most of them are, have an MTech or an MSc in a core discipline. We have had a few people come from the education background, one from psychology also, but largely they are from STEM disciplines, which means they have training in one of the traditional core disciplines. And then they think about what practice is actually meaningful in their discipline. And there we, in that, so then they build what is called technology enhanced learning environment. So they think of appropriate pedagogical strategies, they figure out which are the technologies which are appropriate, which can afford something useful, and they design these. So that's the example that I would like to give. The guiding questions for our research, we have 2 guiding questions, they're related. And this goes in a technique, not a technique, I would say in a more of an approach called design-based research. One question is about the theory of developing expertise, that what is the process or what are the mechanisms by which learners and experts develop practices. So this is actually a microscopic theoretical understanding. And we use techniques like cognitive ethnography to understand this. The second is, how do we design learning activities and scaffolds to support learners' development? So this is the design aspect. So the first one is the understanding and the theory aspect. The second one is the design aspect. These two go hand in hand. In order to do this, so over the years we've developed a framework which we call as LEAP framework, Learning of Engineering Practices. And if I have to just condense it into a single line, this is really an oversimplification, but if I have to do it, I would say that make learners do activities at progressively higher levels of abstraction. What does this mean? Okay. The model on the left is a LEAP model. So first, we give learners lots of activities where they just do a task. For example, they create a graph. They actually do some graph, or they do a small analysis, or they solve this part of a problem. This is very structured, kind of like the back of chapter problems, very mighty. Then we go up and we ask the students themselves, does your answer make sense? The problem that's given is open-ended, large, I'll show you examples in a minute. So we don't say, you're right or wrong, but we say that, we help them come up with techniques. We help them learn techniques to evaluate if their answer makes sense. Then we give them training on, or rather they have to figure out, they have to articulate, they have to reflect on how they solve this big problem. So they do a lot of these tasks. This is not a single task. There's a lot of chota tasks. Evaluate the goodness, go back and forth. You see these dual-sided arrows. They do a lot of metacognition, monitoring, control, reflection here. They go up a level. At this point, they are synthesizing. They have to articulate. They have to say, this is how one solves the problem. And finally, we sort of go towards the expertise, towards the expert levels and say, how will you solve the next problem? So we actually make them articulate and reflect and write and speak answers to such questions. Often it's with the help of technology with prompts. So here is an example. Okay, this is from the thesis of one of my students. It's called, actually all of these are. So this is called micro-macro thinking. So before showing you what she did, I'll just explain what is micro-macro thinking. In many science and engineering domains, there are some microscopic underlying principles. So here we have atoms, electrons. This is solid state physics, so it's electron hole pairs. There's some electric fields. Okay, so these are invisible concepts, microscopic, molecular or less. In biology, you can have things like DNA. Okay, so that's the microscopic level. And then there's the directly observable macroscopic level, which are currents and voltages. And the big problem is that students, there's a lot of literature, and you also, I'm sure, know that students can't see the link between these two. We teach this part in the theory course, we teach this part in the labs, so there's a disconnect. Sometimes this is taught in second year, first sem, and this is taught in third year. So there's a temporal disconnect. And students really can't, when they're looking at oscilloscopes and looking at currents and voltages, linking it to how the valence band or the conduction band, how it worked, it's not very clear. So the idea was macro-micro thinking needs to be explicitly nurtured, explicitly developed. So what Anura did, that's the student, she came up with what's called she came up with a technology enhanced learning environment. This is just a screenshot. What all did it have? So at the core of it were simulations, variable manipulation simulations. But it was not just that. There were questions. Where is it? Okay, the question, sorry, is not on this slide. But there is a prediction question. I think it's here. There's a question which says, if something happens, predict the graph of current versus voltage. So the student would go, and the student would be given multiple choices. The student would pick an answer. I think this is the slide after it. Based on the student's answer, the technology, she programmed this. Okay, the technology would automatically say that, look, your graph, either it matches or no, it doesn't match. And there's a guide me button. There are on-demand hints. So I think this is a collage. This is not a single screenshot. There is a pedagogical agent to guide students who would kind of keep popping up and saying it. This one is not based on any AI. It's actually all based on sort of a lookup table. Okay? It doesn't have any sophisticated technology, even though you can do it. You can add intelligence here. But even without an intelligence system, you by designing several paths for the learner, and by designing several such activities along with multiple representations, hints, feedback, the learner could be taken to making these macro-micro links. So she did this for about 5 or 6 problems. This is a PN junction problem. Each time the student logs on, each problem takes them about 2 hours, maybe 2 to 3 hours. It's okay. I mean, the assumption is they know a little bit of the concepts, but they can sometimes even pick up some of the concepts here. And then what she did is she did a bunch of studies. I'm not going to go into any of this. I just want to focus that she did 7 studies here with, these were sort of quasi-experimental design studies. And she did some qualitative studies where she looked at exactly what they do on the screen, moment by moment, trying to understand where they face difficulty, how to redesign, as well as how they were actually making the macro link. Okay? So this is sort of a nutshell of her entire thesis. This took about 5 years to go. So her key findings was that students who learned with MicroMap, that's the name of her learning environment, they improved on micro-macro thinking. How did she measure this? Okay, that question I'm sure one of you would ask. So she had come up with post-tests where students would be given similar problems to this, but not identical. They were given a macroscopic situation and asked to argue based on microscopics, what would be the graph, what would be the behaviors, what would be the way things moved across time. So similar to what we do often in our electronics classes, but trying to make these connections very explicit. And then she coded them using rubrics. She didn't code only on the right answer, she coded on a lot of intermediate steps also. And what she found out in terms of the theoretical contributions was she identified tasks and metacognitive prompts in the micromap environment, which can, a metacognitive prompt, for example, is a pop-up for a student which says, are you sure this is correct? Can you go back and check? It could be something as simple as that. Or it could be, right here, what would be your next, plan your next step here. Okay? So a lot of such prompts kept coming up. Or it would say, are your steps here aligned with what you did earlier? So just questions, thoughtful questions to help learners kind of keep making these connections. So any questions at this point?
There is one question from one student, and she wants to ask that online mode, there are problems of concentration in virtual mode of education, as the virtual mode can't properly display the wholesome image of concepts. So what to do?
I agree. It doesn't do it. I'm sure all your instructors also agree. Why don't we do one thing? No, let me just finish the disciplinary practices. We'll come to this because there are certain things instructors can do. Yep, I'll just come to this. Anything else about the micromap disciplinary practices? I just wanted to go into one project in detail. Again, this is like 5 years of work summed up in like 10 minutes or so.
So, I just want to say, if we have to, it's the policy implications, if we have this thing, or maybe if I want to replicate a similar thing in another group, which is there, or maybe you can say that here, maybe some sort of, when she selected some kind of sample for her experiment, is there a requirement for
Yeah,
that?
definitely. Absolutely. So there's a whole way of doing the sampling here to make sure that it's representative. And sometimes we do rich qualitative studies. So I'll show you an example here. Actually, I don't have the studies. This is a more recent PhD student. She is a postdoc in Switzerland at this point, and her thesis got the Best Thesis Award in the institute in 2019. Her thesis totally had 15 students, but she did very in-depth ethnography. Yeah. So it's actually odd saying engineering and ethnography, but there are techniques called cognitive ethnography where she studied 3 experts and 15 students on how they do estimation. What is estimation? A question like, you have to build an electric car with all these requirements. Can you use the motor of a vacuum cleaner to build this car? This is all that was given to students. These were like third year engineering students, second year, third year. And then she created technology. I'm just showing you screenshots here, okay? Later I can give you the link of some of these, where this was based on modeling. So one of her contributions was modeling of the system is very important in estimation. That was actually a new finding. New finding in the sense, in a new theoretical finding. And then she designed model contextualization prompts, model evaluation prompts, expert guidance. And then she built a simulator. So there was a simulator which was sort of sitting outside of these prompts. And the student was guided to go back and forth between the simulator and these prompts to solve the problem. They were not, it was not that these were hints to solve the problem, but these were like, okay, build a model. What does your car look like? What is a car supposed to do? What are the dominant parameters? Which of these parameters is important? Which ones are you ignoring? Does your list of parameters affect power? Have you considered power? So a lot of these questions kept popping up and students had to use those to solve the problem. Most of this was power related. So yeah, sampling you have to figure out. Then instrumentation, coming up with valid and reliable tests. The ones I'm showing here, these were not self-perception surveys. These were all actual tests of the practices itself. So there would be an open-ended problem which would then be coded using rubrics and so on. Of course, you can do some self-perception questionnaires also, but validity and reliability is a whole, it takes a few months to get that straight. So a lot of methodologies involved. This is one on biology and genetics. I'm just going to flash these. This is one on software design. This is the most recent. She graduated in July this year. She was trying to help students learn software design, like design a mood-based player using what's called functional behavior structure framework. Okay. So these are our PhD students' work. And in addition, we have done work with faculty members from other departments, other engineering and science departments. So here is one example. So this was actually a large collaborative partnership between two faculty members. So this is me actually, and this is a faculty member from EE. A team of 5 TAs, 5 or maybe even 7 TAs, many from EE and 2 from our department. So it was a large course, okay? And they implemented, they wanted to do a flipped classroom. And the instructor had done it in the previous semester. But he wasn't sure how to measure whether it's working. And he also needed some help saying, look, classroom engagement is missing and am I doing things correctly and so on. So what he was doing is out of class videos. And when we came in, we did a few things. For example, we said in the class, out of class videos, what he was doing was great. But in class, he was kind of asking, oh, do you have any doubts? What do you think? It was more open-ended and it was kind of not very productive. So we brought in certain research-based active learning techniques like peer instruction and think, pair, share, and help the TAs design in-class active learning activities. And then we did a semester-long study on the learning effectiveness. Okay? The technique was called pivoting. Our students named it. It stands for something. What were the goals of the course? The instructor wanted.
Just to interrupt you, can you give some example of the activities, maybe one particular activity which
Sure. Let me just see it. Yeah, I'll just put this. I'll give you an example. Okay. So for let's say the goal of the student, the goal of the instructor was any of these. Okay. So if you look at these are very conceptual, right? They're very core conceptual in nature. These are not just words, but they have action verbs here that students should be able to choose devices for a design. So MOSFETs, JFETs and all. So in the class, let's say they'd looked at they had been taught some of the theory behind it in the videos, some basic concepts. In the class, they'd be given a multiple choice question where they would be given a new scenario and asked to pick which one of these is more appropriate and is more appropriate. And there would be 3 choices, JFET with this configuration, MOSFET, neither, both, something like that. They had to vote. So there is a technique called peer instruction where it's basically multiple choice questions and voting. But after the first round of voting, students in groups of 2, 3, 4, they discuss with each other, they debate, they converge on answers. So the multiple choice question is framed so that it's actually not easy. There's a range of responses to begin with. So a lot of peer instruction. And then there's one more technique called think, pair, share, where, for example, if I take any design question, in the think phase, students might be asked to come up with just 2 different principles behind the design. Very simple 2-minute task. Write 2 key principles underlying the design. Take 2 minutes, write your question, write your response. Then students are asked to pair up, and then they're told in pairs to choose one of the principles, come up with a conceptual design, 15 minutes or so. Small one, more drawing, conceptual, no numerics yet initially. Maybe do a few, just figure out which are the mathematical equations. Then in the share phase, the instructor would ask different groups to share their design and talk about pros and cons of the different methods and different principles. So this think pair share activity can take about half an hour. It could even take 1 hour. But the advantage is in 1 hour, the instructor and the students have gone over 3 different ways to design a particular device. So think, pair, share, and peer instruction are 2 very specific strategies. I can share links with about both of those. Okay, and we have also given a lot of talks about these 2. So there are videos of how to design TPS, how to implement TPS, and all. So just share those links.
Professor Murthy, a quick question here. I just
Sorry,
want
that was
to
a high-level answer. Huh? I know it was a high-level answer, but yeah, go ahead.
I'm just trying to understand what is the class size we are looking at for these exercises?
This one was about 50-ish, this one. But we have done similar things in a CS 101 class of 450.
Okay. So it is scalable, right?
It is scalable. Especially this peer instruction and think, pair, share, they are scalable. Scalable in a way because you're at times you are, it looks, your goal is to give attention to students, but of course you can't give individual attention to 50 students. Instead, you think of them as maybe 8 groups. And in 10 minutes, it's possible for the instructor to go around the class. I'm still talking of face-to-face, okay? We'll come to online in a few minutes. But it's possible to do it, peer over their shoulder, see what they're doing, give them a little bit of feedback. This can be done if these activities are very, very carefully designed. So the videos that I'll share has those guidelines.
Thank you.
What are your class sizes usually, typically? Right?
So our first year intake currently is about 450 to 490.
Wow, okay.
We would be breaking them into 2 batches, and the first year basic courses would be taken by about 250 students.
Okay, so I'll just skip all this. There were some findings, again, this was a semester-long study. So I think I'll just come to the end and then we can discuss. So what I wanted to, the 2 takeaways that, from my end were, one is tech expertise is interdisciplinary, right? You need the disciplinary prior knowledge. Like this flipped classroom example, we really needed the domain instructor and the EdTech team, not just the domain instructors team and the EdTech team to work together. In the previous examples of the PhD students, it was like the PhD student and guide together did bring in both disciplinary prior knowledge as well as expertise in theories, learning theories. By learning theories, I mean, some of these come from psychology, a lot from cognitive science, some from neuroscience, but we use a lot of modern day cognition theories like embodied cognition, distributed cognition in our work. Technology tools, of course. So here, the thing is, so I don't know. I mean, I'm not a tools person. Okay, I know some very basic programming from my physics days, but I can't program. Some students who come with a CS background can. So what we do is either we pair up or we hire programmers who we guide. We give them very strict requirements. We even sort of break it down to some small levels. And what my students tell me is that these days, no code app development is the rage, apparently. There's so many libraries and so many no code platforms. They say that to do things to a certain extent, it is possible even if people don't write lines of code. That's what they tell me for the simple apps. But you don't need a thorough understanding of technologies. We need to know how to design experimental studies, how to do qualitative research, how to do large and quasi-experiment designs, how to analyze data, how to use statistics. how to, so not all of it, but a large part of this. If we can, even up to policy. So I should have put, this is actually, I mean, I should have put dots or put this in gray. So I would, I mean, I have a sort of a soft line here, a dotted line here. I don't know policy, but I'm getting into it a little bit because through that, some other projects. But the point is this expertise is interdisciplinary. So at least in a department. So the main point is within a department, it's highly desirable to have people with this combination. So we need more EdTech graduates, right? Growth of, I like this phrase from your workshops. The growth of the next generation EdTech needs trained experts and specialized presence in academia, of course, but in industry and policy, in the governments also. We need these people who can design for our local contexts. How do we go about doing it? And I think this is the last point I wanted to say. We need more academic departments. We don't need centers, but go beyond centers. The centers will focus on outreach, maybe on curriculum development, definitely on what to do in COVID, how do we engage students. So that's the role of centers, highly, highly important. But in order to be able to actually do next generation thing, again, both tools and learning, we need the research departments in IITs. We need to recruit faculty who are formally trained. We need to offer courses. We need to start these programs. So as, yeah, this is kind of a message. I think that I'll sort of stop here and I can take any questions until whenever Professor Preeti says it's end of time.
That's certainly. So yeah, Himanshi's question yet to answer about
about the online mode, no? That one?
Yes, the virtual concentration in the virtual mode of education is can't display the proper wholesome images of the concept.
Okay, so let me do one thing. Okay, I'm going to share something else. I'll just show you what are some things that can be done. This is basically okay. So this is the self-paced course that I was talking about that we developed last year. And here, if you look at the principles of online instructions, okay. So there are some principles. Let me go to the useful ones. There is something called a reflection spot. Actually, I'll come to that directly. There is something called a learning dialogue and something called a reflection spot. So one of the key principles in online learning is don't give 45-minute or 1 hour long lectures, because that medium is not suitable for long live lectures. If we are doing an online course, split it between the synchronous and asynchronous. Synchronous are the live lectures. Asynchronous are where we have short videos with what are called reflection spots in between. So a reflection spot is basically where the video stops in between or the learner is asked to stop. And there's a small question. Just see where, I'll just show you an example of a reflection spot. I don't think it's there in it, but I'll show you other examples where the video and this can be easily programmed with existing technologies. So there was a technology called H5P. It was open source still like a few months ago, but there are many others where you can take a video and put a automated question in between. It's possible to program it so that the video stops, the learner does the question, types something in and goes ahead. So create short engaging videos is one thing. Secondly, I'll go back to the principles. Between videos, give practice. So every 5-minute video should be succeeded by 1 or 2 small questions on it and intersperse them, interleave them. So I completely agree with the student who said that, look, we can't, if you draw something and only use that, it may not be very engaging, you may not be able to see it. You can use tablets to draw, but use that for certain times. Then Of course, there may be animations and simulations which others have created. So your job as instructors should be that of a curator, like a museum curator, right? We take all the good things that people have already created. There's like tons of good online educational material, starting with NPTEL, which our own colleagues have done. You can make your own also. So this website tells you how to make your own. But you can also be a curator. Refer them to somebody's talk. Refer them to an animation, to a diagram. Bring them back with questions. So the way we think of online learning, there has to be a bit of a mindset shift. Like in a classroom, we go in saying, okay, these 50 minutes or 1 hour, I'll be here 3 times a week, and then I'll give homework later. Here, that idea has to be just shuffled a little bit. I don't know if I answered. I know it was not a direct answer, but it's kind of a principle-based response to all these problems we face about online instruction. Do peer activities in online, sorry, to one. It's leverage peer learning. It's very possible in an online forum to do peer activities. Your technology can do breakout rooms. If your technology can't do it, between two synchronous classes, give them a peer activity where they have to do something and post something. Everything students do should have a deliverable. It could be small, but it has to be a very well-defined deliverable. Then they also feel that they've done something and you also know what the progress is. Yeah, sorry, back to you.
Yeah. So thank you so much. So there is one another question on this thing. So this is what step can be taken regarding the demographic challenges already facing higher education, and how edtech can intervene, which is already deepened during the crisis. So how we can help in that?
So I'm going to tell, okay, this is something I don't personally work in a lot, but I know that a lot of people are using edtech for scaling. And by scaling, I mean not just to numbers, but to geographically remote areas, to languages. So I'll give you a couple of examples. There is a product company for the school level, and they have a product which is an adaptive learning product. They call it their $100 product. They realize that more than half the students in India, they have a smartphone, but they can't afford a $100 product. So they created a $1 product where they use some video of repositories and they use WhatsApp. So they combine WhatsApp for communication, for giving these activities, along with a repository of videos which they can even ship to people or send to schools. So they're using edtech to reach out to students who are either economically disadvantaged. So there are all these things, right? That half 500 million, 300 or 500 million households have smartphones. So the idea is let's use them, not just to populate content, that is also done, but how can we use it effectively along with schools so that quality education can make its way. So commercial products, in fact, are doing a great job here. That's one part of the answer. The second part is about languages. So in IIT Bombay, there's a big project called Spoken Tutorial, where they are getting IT literacy, programming, as well as, say, getting senior citizens to buy a ticket on IRCTC, standard computer literacy. Now they're even moving into maternal health and other healthcare related things. And they have dubbed it and translated it into maybe 20 odd languages. These are less than 10 minutes long audio plus a screenshot of how to do something. So scaling to diverse audiences, geographically far off places and all, edtech is doing quite a good job there. What is hard to do is to quote unquote prove learning outcomes because you do it.
Thank you so much. I think Dr.
question,
Raj, yes.
Yes, so very briefly, I would like to ask this, Professor Murthy. So how do you see a subject matter expert, like in the conventional terms, how do you see a subject matter expert eventually becoming a successful instructional designer? Do you think subject matter experts should go in that direction? Do you think it's possible? If yes, then what kind of training or what kind of
Are you talking
preparation?
about instructional designers mostly using technology? Because, okay, the reason I ask is, I think every instructor by definition almost is an instructional designer. May not be in the sense of the word that industry might use, but every teacher does instructional design, right? At least for face-to-face class. So we will get this criticism, right, if we ask that question. So, let me take the liberty of rephrasing your question. That suppose now it's for the online medium or using technology and all. Should they learn? Can they learn? So can they learn? Absolutely. Because again, a lot of instructional design is based on a few key principles which most subject matter experts implicitly know, even if they're not, if they don't think about it explicitly. So this idea of outcomes. People, the moment you say, even earlier, I pushed you, I asked all of you, make the word understand more precise. And immediately, students should be able to do problem solving, they should be able to apply, it comes up. So with some guidance, getting the basics of instructional design for the online medium and all is definitely possible. That's what we did last year, actually, with this course in our institute and many other ISOs and IITs. There's like a 1 hour work talks on this online teaching. Again, I'll send you all the links if you want. They're on my webpage also. So it's possible, Mr. Raj Lakshmi, and it depends on how much they are interested. But I would suggest, if you ask them, they'll say, of course, they do instructional design.
Thank you, ma'am.
Thank you
Just
so
one
much.
last point
Yes.
related
Yeah.
to that. What I have found to be productive is when either the instructional designer and the subject matter or I wouldn't say designer, but the expertise in subject matter and the expertise in instructional design, if these really are within the same person, or these two people talk to each other a lot, at higher ed especially. So we had a project 10 years ago where we were coming up with animations and simulations, and we had SMEs and we had the IDs. And it didn't work so well because the IDs wanted to do something, they didn't understand the subject. The SMEs were like, look, this is not the way to do it. But in one topic, the subject matter expert who had a little bit of idea of outcomes and some of the theories, it worked very well. So at the higher end, this is a personal bias I have, that if the two skills are within the same people or same group of people, it's more productive than kind of separating them into two separate stand-alone teams. Yeah,
Agreed. Thank you.
So there is one more question which is there, and this is by Professor Natasha. She wants to ask, in peer learning, or what we call peer teaching, a limitation she found was the difference in levels or streams of each student that often leads to miscommunication, which could also be because of difference in disciplinary training that equip the student with different perspective. How do you tackle such a problem?
Yeah. Mixed group of humanities and non-humanities. Okay, thanks, Professor Natasha. This is a very common situation, which happens. So, what the research suggests, couple of things here. This is more of a suggestion which you can try. Having group activities which have a little bit of structure, where it's very clear what the students are supposed to do and how to do it. At least initially, structured or semi-structured tasks are better for peer learning than completely open tasks. So what doesn't succeed is if we say, go on Moodle and discuss or post on the forum. So it doesn't work very well. I think humanities instructors are much better skilled in face-to-face situations in getting classroom discussions going. Engineering instructors are not trained to do this. That's the way it is. But in the online setting, one example is we've come up with a small strategy called learner experience interaction. What we do is we first give a very focused question, where instead of saying discuss, we say, so let's say this was a course actually for teacher trainers. So it was like which was students from B.Ed, M.Ed, and all. We told them that here is a new strategy and you have to go and do something. Post on the forum one challenge you faced when you were implementing it. So they all went and posted. It's very specific, right? The second part said, go and visit 5 of your classmates, your colleagues' forum posts and offer suggestions to 2 of them. So again, there is a structure here. And in the third part, we asked them to submit what were the 3 most commonly observed challenges and 3 solutions which were. So all I'm saying is, if you take an open question and think of putting a slide structure where learners know what exactly group A has to do, what person A has to do, person B has to do. Maybe have them do roles, driver navigator type of roles. Some sort of specific things that person A, B, and C have to do, and a deliverable at the end. That write this, post that, draw this diagram, together as a group, upload something. That has shown to have a lot more people doing things. The heterogeneity in difference in levels, actually, again, if the question is slightly challenging so that it needs people with different skill sets and all to participate, that has also been known to be a bit useful.